What's up, audience? Took a brief break from making videos because I was doing other stuff, and now I'm back and we're going to be connecting this floppy drive, instead of through here, we only have one of these, directly onto here with a bunch of wires and stuff. So I have this thick wire which I'm going to put into these holes, and then this slightly thinner wire which I'm going to put on these power things here and then connect it onto that. And then with these two floppy drives we'll connect them together, and then I'll code something up and we'll see if we can get something that'll actually play like two things at the same time, and hopefully it'll be pretty cool. Alright. It's time to wash the hands, and then coding. Hand washing first. Alright, so before I actually connect it up, I want to measure how many times a pin can be flipped in some amount of time, let's say a second. Now, Arduino does have PWM pins, but I'm not sure if I'll be able to use them because... Alright, so my plan, right, is if I were going to have a direction pin connected for every floppy drive, as in like a separate one for every floppy drive, then I have about 20 available pins to be used on the Arduino. So if each floppy drive needs 2 pins, then I'll only be able to get a maximum of 10 floppy drives on there. But I want 16 floppy drives. So my plan is to just use one direction pin to do all of them. Since there's no threads, then well, essentially you're not going to have 2 floppy drives stepping at the same time, which means we only need one direction pin. But if there's like some limit or something for how much you can pulse a single pin as opposed to like a set of pins, then this could have problems. So I'm just going to test it and see how that goes. And I'll look into the PWM stuff and see if that will be useful, but I think that might only be for like a set frequency, because if you have a bunch of different floppy drives and they're all playing different frequencies, then your direction pin is not going to be like, it's not going to be flipped every like X, for X is constant microseconds. It's going to be like all over the place. So right. Alright, so this will be our start time. I think that works. It's been a while. It's quite hard to remember what to do. Don't want that. And let's have it go, let's have it do 10,000 flips. Okay. Alright, this should work. Whoa, options, what do? I think it was... Alright, so 10,000 toggles in 80,000 microseconds. How does quit? There we go. Okay, 80,000 microseconds. 8704 divided by 10 to the power of 6. That many seconds. 10,000 in that many seconds. So 10,000 divided by that. We can do about 123,000 flips in a second. So if I change this to millis, and then set this to 123,000, we should get out about 1,000 millis. Yep, I'm a retard. Herpaderp. Cool. So we can flip it 123,000 times per second, and the floppy drive can only go up to a max of 400 Hz frequency. So 16 times 400. Yeah, it'll be fine. It'll be fine. It'll be totally fine. Yeah, it'll be fine. Alright. I'll connect up the floppy drives now. And then we'll play Nyan Cat with left hand as well, and it will be glorious. Alright. Let's connect up the Arduino to these floppy drives. Here's my Dodge ground thingy. In it goes. Alright. Now, let's see. I think that this normally goes in this way. If I don't, then I'll be connecting the 12 volt to the 5 volt and the 5 volt to the 12 volt, and possibly stuff will blow up. But we'll see. I'm sure it'll be fine. Let's stick to the convention they have. And have yellow for 12 volt. Oh, the colors. The colors. We'll have red for yellow one, 5 volts, whatever. And then black, sticking to the convention again, for ground. We only connected one wire onto ground because effort, and they should be connected anyway. So, even if they're not, I'd be a little surprised. Looks like this one might be a little bit hard to get on. So we'll just troll and connect onto this one. Alright. Man, I'm gonna need so many of these. don't need that. Oh, looks like I might have enough left, maybe. Alright, green for direction. And that goes on there. White for step signal. That goes on here. Another white for step signal. That goes on here. And now we still have to connect the drive select, I think, to the ground, and the other direction to that direction. But none of these are touching. Let's just push them down a bit. Alright, time for trolling. Disconnect these two. Pull this down. Come on, reach. Now connect this one on here. Oh, so fiddly. Alright. And now this other one. This one's a lot easier because it's closer. Now we can put this one over here. Yep. On the end like that. This will totally work and does not look dodgy in the least. Let's try it out. Alright. So I'm driving 2 floppy drives here. I think we will do this. Floppy drive. State it needs to store is well, it'll need to know the direction that it needs to go next. For the time being, let's have it like that. So you give the floppy drive the wavelength, then you have a function void way. We pass it in the time. Yeah, okay. And then it will need start time. Alright, so based on the time, we either want to digital write high or digital write low. Okay. It'd be better not to pass this in actually, and just would it? I think this will be a bit more accurate doing it this way. So now we've got the number of macros since we've started playing. Perhaps it might be better to separate this functionality off into a separate class, like note or something. That's how we do this. I'm getting this bizarre, like sort of like drifting behavior on the heads. So like instead of staying in one place, they like kind of move around. And also when I tried to play two at the same time, it's like really weird. Anyway, deal with it on the next episode. See you, broskies.